Hey students, welcome back for another Unit 3 video. We're continuing on Unit 3, but we're kind of shifting gears. So in the last couple of videos, we talked about intermolecular forces and we talked about solids and liquids. And last video, we talked about kind of all three, solids, liquids, and gases. Today, we're going to put it a little further into practice and we're going to talk a little bit more on gases. The other thing about this video is this is our prior knowledge video. This actually is not listed in the AP Chem curriculum, but they expect you to know it for the AP Chem exam. So let's just jump right in and we're going to review empirical gas laws. All right. And so empirical means simplest. So that's what we're talking about here, simplest. But let's just go ahead and jump in with a quick review of pressure. Pressure, if you remember, is force per unit of area. So how much force is being put on a system or the walls of a container or other molecules as it's bouncing around in there. So we're talking about that in terms of pressure. So if we look at our terms of pressure, and there are a few of these on your laminated sheets or on your cheat sheets, if you will. So here's what we have. We have 1 atm equals 760 mmHg, 760 torr, and 14.7 psi. This one's the American one, right? And we're not going to use that in AP Chem, but I think it's good to also know this as a conversion because, well, our tires are in psi, so it's kind of cool to know that about them. Okay, so how we measure pressure, and this is just kind of a quick review of vocab. First off, a manometer. A manometer is one that just measures pressure. This is a thing that measures pressure. All right. And so this could be in the lab. We could use a manometer. All right. So these measure pressure. And then we have the barometer, which measures atmospheric pressure. All right. And this is what they're talking about, like, on the weather, when they talk about, oh, there's a high pressure system moving in, they're talking about atmospheric pressure, and they would be using a barometer to measure that. But I just wanted you to know these things because I've seen manometer used in a AP question before, and it's helpful to know what it is. All right, so jumping down to our empirical gas laws. These can actually all be derived from the ideal gas law, which we'll see tomorrow. But for right now, it's kind of good to just kind of review these empirical ones, these simple ones. So Boyle's law talks about our relationship between pressure and volume. And in very simple terms, it says that as pressure goes up, volume goes down and vice versa. All right, so our formula that we use there, or the one you learned in your last chem class, was probably P1 V1 equals P2 V2. And the only key here is that, remember, our pressures both need to be in the same unit and our volumes need to be in the same unit. We couldn't use milliliters on one side and liters on the other side. Okay, then we have Charles's law. Charles's law is our relationship between volume and temperature. So as volume goes up, temperature goes up, and that could be vice versa. We could be saying as the temperature goes up, the volume goes up. Think of like expanding a balloon or even a basketball in the summer versus winter, right? In the winter, it looks like it's flat because it's losing that volume, and in the winter or in the summer, it looks bigger because of that. So our formula there are a couple of ways you can look at this. If you're good at manipulating formulas, you could go V1 over T1 equals V2 over T2. If you're not so hot at manipulating formulas, you can actually rearrange this to V1 T2 equals V2 T1. In this manner, you don't have anything in the denominator, so you don't have to worry about those little issues there, right? The key here, this is a star, our temps have to be in Kelvin, all right? We have to convert our temperatures to Kelvin. And to do that, remember Kelvin equals degrees C plus 273.15. All right? And I believe that's on your equation sheet, but if not, that's probably something you should know just anyways, all right? Last but not least, we have Avogadro's law. Avogadro's law is our relationship between volume and moles. And this is also a direct relationship. If we look at Boyle's law, that's indirect. Charles is direct, and Avogadro's is direct as well. So that means when number of moles goes up, our volume goes up, which makes sense if you think about it. just making sure that we know like they both go up, right? If volume goes up, I'm going to have more moles of a gas or a substance. So again, this one looks like N1 over V1 equals N2 over V2, right? And we could rearrange it N1 V2 equals N2 V1. And that's just a quick review. Your homework today is just practicing putting these handy dandy formulas that we just put right there into practice. Okay, see you on the next one.